Let's look at a new kind of math task, one that can't be Googled, one that's too complex for AI to answer with a clean solution, and one that gets students thinking, synthesizing, and designing. If the math task is static, predictable, and close ended, AI will solve it instantly. But if the task is messy, is real, and designed for human judgment, AI becomes just one tool in the process. In this episode, I'm going to show you how to design performance based math tasks that use AI to support students without it doing all the thinking for them. We're calling this strategy AI Math in Motion. Let's go. Start with a real world situation, one that requires math but doesn't end with it. For example, you can have students plan a school event with a strict budget, design a sustainable garden for a local park, compare rental car pricing models for a fictional road trip, and or create a business plan for a student-run pop-up shop. These are scenarios where math shows up, but where it's only part of a bigger real decision. Here you can ask students to design the problem, not just solve it. The assignment could ask the students to use AI to help brainstorm a real-world math problem involving exponential growth. Then they can revise it to fit their community, their interests, and their level. This is performance because it blends math, storytelling, and strategy. AI can help with ideas, but students choose, refine, and justify. You can require multiple models and comparisons. Do not stop with a single solution. Push students to compare linear versus exponential models, test two different budgets, create two graphs showing different assumptions, and analyze how small changes in one variable affect the outcome, and prompt to ask the AI to explain the pros and the cons of each model, then critique that explanation. Now they're not just solving, they're thinking like analysts. You can also have them build in an element of judgment or design. You can ask them, which design is more cost effective and why? What makes your plan realistic or efficient? If you had to defend your solution to a community board, what would you say? You've just added purpose and audience, and this makes cheating nearly impossible because the response must be personal, reasoned, and situated. You can scaffold the experience across multiple days. Performance tasks, not one day assignments. They unfold over many days. Day one, you can help them explore the concept. Day two, use AI to brainstorm real world problems. Day three, draft the scenario and math needed. Day four, solve, revise, and compare. Day five, reflect, present, and justify. Each day includes opportunities for reflection and revision, not just submission. Require AI prompting logs. Students must record what they asked AI, reflect on how it helped or confused them, compare AI's reasoning to their own. Now we can see the thinking trail, not just the outcome. You can emphasize visual representation and explanation. You can have students create graphs, diagrams, or annotated equations. Use visuals to tell the story of their solution. Record a short video explaining their model and process. This shows procedural and conceptual understanding layered together. You can score for reasoning, not just results. A sample rubric will have 20% go to quality and relevance of the scenario, 20% go to accuracy and of the math, 20% to clarity of comparison and judgment, 20% for the use of AI for support and not substitution, 20% for the presentation and reflection. Notice, this is not about correct answers, it's about real engagement. You can celebrate this type of project by letting students share their final performance task. They can do this in class, on Flipgrid, or video, or even have a student math expo. You can have students prepare to answer questions such as, what did you create that you're proud of? Where did the AI help you grow? What was the hardest part, and what did you learn from it? This highlights their learning and math using AI as a tool rather than a shortcut. Because remember, math is not just about solving problems. It's about designing them, modeling them, testing them, judging them, and communicating them. And when we give students performance tasks that live in the real world, AI stops being a threat and it starts being a guide. Remember, AI can only generate content, but only students can generate meaning.